Okay, today we're going to take a look at multi-part machining. If you go to Moodle and go to the SolidWorks folder that I have in Moodle, you will see a multi-part machining mt3.zip file. Download that file, unzip it and open the assembly, and you should be presented with this setup here. Here we have a fourth axis, a rotary axis, and on that rotary axis we have a jig fixture which is called a tombstone, and we have 4 parts which are fixed onto the tombstone with these brackets and bolts. So we want to set up our machine, but prior to do that I'm going to set up the coordinate system. So just click on coordinate system. I have a coordinate system predefined in my SolidWorks model, so we're going to use that. So click on SolidWorks coordinate system, and the coordinate system is called coordinate system 1, and you should see it appear here at the end of the tombstone, on the end of that face. Press accept, and as I said, if you press on the coordinate system you should see it highlighting there with the x-axis lined up with the 4th axis. So now we're going to define the machine, and the machine that we're going to use is a 4-axis mill, metric. Press select. And the tool crib, I'm going to start with an empty tool crib and add the parts or components that I need. So I'm going to press the add tool. The first tool I'm going to use is a flat end mill, and I'm looking for a 20mm flat end mill. So scroll down, 20mm, press OK. Next up I'm going to put in a center drill. So add tool, select center drill, and I'm looking for a 10mm center drill. Press OK, and then a 16mm drill. So add tool, change to drill, and we're looking for a 16mm drill. And finally a 20mm drill. So add tool again, drill is still selected, scroll down till I get to 20mm. And press OK. So that's my tool crib set up. Now I need to set up the rotary axis for the machine. So I'm going to click on rotary axis, and I would like the rotary axis to be rotating about the x-axis. Okay, so that's fine. I can see the position over there. That's great. And I would like the 0-degree position to be set up from the XZ plane. I'm happy with that. Press OK, and now we're going to set up the part. Okay, next up we're going to select the part. So double click on part manager, and we want to select our part and just highlight the part here and add all instances. So we should have our 4 parts here are now added. Press OK. Next up we would like to set the stock. So click on stock manager. In this particular example I'm not actually going to add anything to the size of the stock. But here obviously you would set up your material and so on. And we're going to apply the current stock definition to all parts. Click on that and accept. And now we're ready to extract the machinable features. So click on extract machinable features, and you can see here we have 4 setups generated. Setup 1, 2, 3 and 4, and in each of these then we have our machining for a rectangular pocket, and then we have our drilling operations. So we have the center drilling, and then the drilling of the 16mm holes and the drilling of the 20mm holes. Now what we need to do is to set up the machine with the fixtures so that the machine will not collide with any of the fixtures or the tombstone. So to do that, we enter into setup 1. Now, slightly confusing here. If I double click on setup 1 while I'm in the feature tree, nothing happens. So you must click onto the SolidWorks CAM operation tree and double click on setup 1. Alright, so that, even after using the software for 2 years or so, that still catches me out. Okay, so make sure you're on the SolidWorks CAM operations tree and double click here on setup 1 and click on fixtures, and here we want to include the various fixtures. So I'm going to include the tombstone, I'm going to include the clamp and the bolts. So add all instances, and then we should have all of the instances of the clamps and the bolts selected here. Now we could also add the front plate of this. It'd be no harm, just in case the machine would accidentally collide. So I'm going to add the front face of the rotary table. Press avoid all, and that selects everything for you, and press OK. Okay, before I proceed in generating the operational plan, I want to change some of the default operations that are going to be used from the tech database. So I'm going to click here on the default feature strategy, and I would like to change the default strategy that's going to be deployed for the rectangular pocket. So at the moment it's going to do a traditional rough with some material remaining, which is a rough rest operation, and then a finishing. And I just want to bring that back to a roughing operation for this particular part. So I'm just going to change the click here and change to a roughing operation. Press apply and close. Now I can extract my machinable features, or sorry, generate my operational plan, which will be based on my new default feature strategies. Now we can generate our toolpath, and once our toolpath is generated, we can take a look at the simulation. We start off, we have a roughing operation on the pocket, and that should be followed then by a center drill operation for the holes. Tool change, that's our center drill. You can see we're center drilling and drilling the holes, and after each part or that can be machined on that particular plane is finished, then we rotate the tombstone 90 degrees and it continues the operation. And this is our final 4th part being machined. Center drilling, and the part is finished. Take a quick look at the show differences. That's fine. And I just want to check that I have pause on collision activated for the tool and the shank and the tool holder. So I just want to run that again and see, am I getting any collisions? Speed it up. Alright, according to the simulation there's no collisions there. What I am going to take a look at now is how to improve the efficiency of the machining operation. If we're to observe the machining here, we're rough milling, And then we have a tool change where we're center drilling the top. Then we change the tool for the 16mm drill bit. We're drilling the 6 holes. Then we change again to the center drill and drill the part here which is on the right hand side. We change for the 20mm drill. We drill it. Then we change back to the center drill and center drill the part here on the left and back to the drill. So there's a lot of duplication. It would be nice if we could maybe do the center drilling of all of the holes and then change and do the 16mm holes, or do the 20 and then change and do the 16 together. So that should help us with the cycle time. So let's just take a look at the cycle time we have at the moment. If I double click here on the SolidWorks CAM NC Manager, it tells us that this has taken 34 minutes and we have a tool change time is 1.57 of a minute. So let's see, can we improve that? If we go to Setup, right click on Setup 1 and go to Sort Operations and Process Complete Feature. And this is the option that's forcing it to do the center drilling and finish the drilling before it moves on to the next feature. So I want to deselect this. That means it will partially do a feature and partially do multiple features with the same tool and then go back and finish it later on. So that often can be more efficient. In the sorting operation, we would like to do the rough milling. I'm going to drag that to the top. We don't have any contour milling on this particular piece, but if you had, and you could put it up there because it won't affect it because there's none there. So rough milling, contour milling, and then we want to go center drilling and drilling. So the idea is that it will complete the center drilling before it moves on to the drilling operation. Apply, press OK, and now you can see the center drilling. So we have rough milling, center drilling, and then drilling. And we're going to do that for the different setups here. So setup number 2 I'm going to do it for. Again, sort operation, deselect process complete feature. I would like to have the rough milling, contour, drilling, and the center drill and then drilling. Apply. OK. Setup 3, same thing. Rough, contour, center drill and drill. And finally, setup 4. So rough, contour, center drill, and drill. Apply and OK. So now if I go to simulate the press play. We will hopefully see that we will center drill. Alright, we have a rapid collision and we're going to have to sort that out in a few minutes because it's working from the top surface of the component on the right hand side as so there's a clearance there or whatever, 5mm from the top surface before it can do a rapid traverse, and once it goes into that rapid mode it's now cutting straight through the piece here. I'm going to have to fix that. if I take a look at what's remaining, you can see the rapid movement. So we have to change and sort that out. What I need to do is modify the tool path for the center drilling. So if we click on the various operations, we can see the tool path illuminated there in an orange kind of a color. And that's the roughing, which is fine. And then the center drilling for the top holes, that's perfect. Now the center drilling for the holes from the part that are on the right hand side, that's causing the trouble because it's moving from the right hand side to the left hand side and cutting straight through the piece. So what we want to do is to change the rapid plane for this movement. So by right clicking, edit definition, if you enter into the NC tab, so the rapid plane, it thinks is the top of its stock that's over here. You can kind of see the rate pattern. So it thinks once it gets to 25 mil above the top of the stock, then it can move rapidly around it. There's no obstruction anywhere at that particular point, and obviously that's not the case here because we have this tombstone and we have this part and everything above it. So we want to change this to give it a safer height, and by measurement or whatever, I'm going to put that in as 105. If I press OK there, now you can see the height. I'm just going to look at this plane, so I'm going to click here and look normal too, and you can see that gives me enough clearance. Now unfortunately what it's going to do is it's going to go from 105 mil down to the first hole, back up to 105, down to the second, back up to 105, which is very inefficient. So there is another option in here, and you would normally do this while you're in here. I just want to show you the path clearance plane. See, will that do it for me? Preview. There it is. So we want to go down, come up 3 mil above the part, down, up 3 mil, down, and then come back up to 105 before we go across the part. Right. Now I'm going to have to do this with the part on the far side as well. So far side here, right click. Sorry, I have to accept this one first. Press OK. So the same here on the left hand part as we're looking at it. Right click, edit definition, go into NC features. From the top of stock is now going to be 105, and we're going to go from the clearance plane between the different features. Press OK, and that has updated. The same will actually go for the drilling as well. So the drilling on the far side, right click, edit definition, 105, and the clearance plane. The side, edit definition again. So there's somewhat a few repetitious steps in this, and press OK. So once you've done that for setup 1, it automatically takes that information and populates it through setup 2 and 3 and 4. So for example, if I go to the second center drill operation in setup 4 and go to edit definition, and if I take a look at the NC plane, you can see it's already at 105 and it's using the clearance plane. So we should be okay now to simulate, and hopefully that will avoid any collisions. Simulate toolpath. So now we're doing our center drilling, and you can see the height that we're coming up between the transfers and there's no collision. So that part is machining successfully. We'll just take a look at the show differences. So everything is fine. This here is blue on the inside because we're using that roughing operation and we're not going back and contouring it. So but that's fine for this particular piece. That's the tolerance we were looking for. Now let's take a look at the stats and see if we improve somewhat. So we've gone down, the tool changes have reduced, I think they were 1.57 and that's dropped from 0.87, and the total machining time is down to 33.8. So small improvements, but these are the kind of improvements that are important in a manufacturing environment, okay? So, hope that helped. Thanks.